out this presentation. I am not, I learned more about Internet of Things in the last 2 weeks, wasn't it, that we were talking about this? But I certainly have worked with IT and security for some time, and so I think I'll be able to give some perspective on similarities and differences between some of the challenges I've seen in these areas and other places. We have a great program for this event today, so my part is going to make sure that everyone has a foundation understanding what Internet of Things is, what the framework or technical architecture is, what the big hype and actual the motivation or the opportunity. I'll set the stage on the technical architecture, some of the foundations, and then I'll leave the stage before any tough questions happen. Then we'll bring on our resident subject matter expert on security from Verizon for Internet of Things. So we were lucky enough to have someone fly in for this, everybody had to hang out in Waltham and do some work up at the Innovation Center for Verizon yesterday, so I guess he paid his dues the other way. And then we're going to close out with getting a clear understanding of a specific application at the end, and then we can handle questions as a panel or as you go. All right, first about me. As Jeff mentioned, I've been the Chief Information Security Officer at one of the executive offices here at Mass. So it's actually very close to here, just up the hill. Been in security for about 14 years now, been in IT for about 35. I'm the president of InfraGuard in Rhode Island. And InfraGuard is actually an organization that works for the FBI and DHS all around national infrastructure protection. And so therefore we actually just last week we did a maritime security event in Rhode Island, and lo and behold, there's some Internet of Things activities happening in maritime. Who would have thought? So cyber is sitting everywhere, Internet of Things is sitting everywhere. So you're gonna feel that today in terms of our presentation. I have had an organization for some time called Security Beat, which is really to try to continue. So my 14 years of security, things keep changing. So the beat is to continue to follow that risk and learn that new opportunity and try to harness it for maximum gain. And I also teach tonight at ITT Tech at Norwood, Information System Security discipline. First, a definition from Gardner. And this is where you get the first differentiator. Unlike computers as I've grown up with, business information processing, personal computing. The framework here is all around the physical world and the device. So now the device has its own role in life in IT. Unlike either the business driver just using it to process back end or whatever, there's certainly been, I'd say, customized command and control type infrastructures, manufacturing floors that have had automations, things like that. But I think we have a whole new paradigm here where the devices are becoming more prevalent and becoming more interconnected. All right? It's all around using technology to enable communications and interact. So you have to, it's not just doing it in a silo, it really is more the interaction and the processing, and it supports a lot of different business drivers such as big data and big data analytics. So it's all devices, not people. There's a number of different kinds of examples, and there's some graphics on the internet that are much busier than this, but I figured this is one you can actually read. Certainly, in the home, we can relate to the fact that you have an alarm system, perhaps. You might have your temperature controls, always manual, isolated, hardwired. If a wire breaks, it costs a lot of money, somebody's got to run in a wire. everything's changing. It's all becoming network-centric, more intelligence, more integration. So now you can do things like control some of these things from other places. You have multimedia devices such as in the past, like used to be the cable box, the dumb TV, and now it's like everything's got the smart capabilities within it. Don't have to go through the whole gamut here. The idea is almost every area where you've had more, siloed infrastructure, and maybe some very minimal technology or electronics, it's now becoming computerized and networked. When some of the entrepreneurs in the audience look at this slide, they start to think, well, there's definitely some opportunity here. Because guess what? We're predicting this rapid growth of this space. So, and I've actually seen this number different analyst estimates. But IDC, which is right around the corner here, did a study and predicted, I don't know if you got the date of when this was, it's not this year, so it's probably a year old and maybe the numbers were wrong. But just in a few years, to be 4 billion people that are interconnected, and all around using, operating, managing close to 25 billion devices. Right, so obviously we're definitely outnumbered now, devices to people. And this last piece of graphic here, which is cut off, is really the kind of data everybody's excited about, because the more intelligence we have for business, it's all around data and processing, and there's some new methodologies, there's new roles out there called data scientists. It's all because of this new fundamental change in paradigm shift. So if we can get all this data, we can put it into these new analytical engines, we can create better processes, better intelligence, better investments, better operations, a lot of different things. Some of you in the audience may actually be more on the development side. There's certainly an opportunity here to help fulfill these 25 million plus applications that's going to evolve in this industry. I don't know what the kind of number is right now, but certainly there's a lot of predicted demand for that space. And for those people digging in your pockets, they look at this as a $4 trillion industry in just a few years. Gartner invented this hype cycle type of a curve, and it's not necessarily always proportional for a given sector that it looks at, but it's very predictable that technologies will go through this type of evolution. So you start out with something initially being invented and adapted, and there's a big productivity gain as you learn and evolve that. And then you, at the top, you ended up, all right, now you think it's going to keep going, and all of a sudden it starts to, the expectations don't live up. Right? And this doesn't really show it, but sometimes it's, the application into real life business that, so we're trying to do more with it, and all of a sudden we're not, and then eventually we find the right place for it. For this particular quadrant that Gartner did this on, Internet of Things is at the very top. And by the way, nothing slides backwards. So we have some learning we're going to do as we try to adopt this. Many people think that this is going to be a very short dip and go out. But there's definitely the need to learn, and that's why part of this is coming to this session, actually participating in that training session, and getting in the lab, because the fact of the matter is a lot to learn. There's more to learn than what we know already. Let's put it that way. One of the big enablers here is hardware. This kind of shows the evolution of microprocessors and stuff, and allowing us to have the capacities to have very inexpensive, high-end processing capabilities down at the device level. So this is not this is somewhat growing almost in that same curve, and it was a curve. And certainly, if you looked at these things, part of the thing about microprocessors, if you ever look at it, is, you know, the more expensive high-end chips go to one thing, but then the other ones go to other things at a much more reduced cost. So you tend to reuse a lot of the previous architectures, and it becomes more part of percolated throughout your infrastructure environment. Almost nothing gets retired, including XP. So this growth creates a number of problems, and I'm going to walk across the problems, and we're going to talk about some of the aspects of the architecture that they expect is going to address this. Again, I'm going to try to get the foundation architecturally, and then you'll be able to then understand some of the control requirements as well as where things might fit. So first off, we have this tremendous amount of devices. We have this address space issue. Right? So one of the things we've been waiting for forever is IPv6. So from an internet point of view, once people are fully implemented, we'll definitely have enough addresses. But obviously, you can see we're going to use up all those new addresses because it's definitely the address space for just the IoT part of the IPv6 is going to be decent. But addressing is one aspect. The other scale. So you have all those devices, so they're going to go to a single backend server, or is there networks that are going to clog up with all this stuff? So there's definitely this issue of how much data can you feed this engine and from where? You have this connectivity issue, and I'm not just talking about bandwidth. What I'm talking about is, just taking the red line down here, it's like my phone probably had a couple of black spots, So what happens with the IoT world? Well, these devices don't necessarily have the network consistency. And if it needs to have reliable communication to do its job, what are you going to do about it? You have the sheer volume of data. You got to process it, but also store it. And then you get some limitations. The whole intent here is not to treat significant real estate in these devices just for security and other things. You really want to have the devices have their primary purpose, and then provide some additional capabilities that like the feedback loop for analytics and machine learning, things like that. Now down across the bottom is components of the architecture. So we'll talk a little bit about this later, but the notion is it's a publisher subscription type model, so such as my smart TV, to be able to get my content, something like that, where devices have identification, they get registered, validated, and so therefore the back-end system's only servicing a subset of this full breadth of internet devices, as well as the front end is not having to search everywhere, it knows where it's going. So that's part of it, in dealing with just the particular data that's being asked for in particular places. The next is the fat cloud, and now that we all know the security's in cloud, we can use it for everything. So we definitely would want to pump this thing into the cloud, and there's certain technologies in cloud that actually make it super, super fast. It's not just like normal back-end mainframe computers of the past. To deal with connectivity, we're going to use a queuing approach. And actually, this is not a unique concept, it's just the technical bits of which ones we're using for the library sets are different. But I know when I was at Raytheon, in certain cases, GTech, other cases where queuing was a method to be able to have reliable message transport and routing within a kind of an environment. So it's not actually a unique thing. It's just the fact that the technologies, as well as it's now not a dedicated corporate or defense architectural endeavor. It's all public domain implementation. So who's party to make sure the message queuing works? Who's going to figure that out if it doesn't work? We've got cloud storage to deal with volume, and then we have some new protocol stacks to kind of help make it lean and mean for the devices so that they don't have to do a lot of work here. And notice at the bottom, I kind of mentioned where I'm getting this stuff from, so I did not create all these slides, and I'm not, Microsoft's down the street, and we wouldn't want to offend them. There's some very good architecture, high-level stuff on Internet of Things for Microsoft, and there's a lot from Amazon, so I just happened to find some good stuff, and this is not a specific architecture that limits itself to Microsoft. It's just a rendition because it refers to the Internet standard protocols. All right, so we have some limitations on certain types of devices, so therefore we have to have different options. So one is the notion of having some kind of a on-prem gateway feature. So now this is dealing with more localization, and then this more sophisticated thing is dealing with the full breadth, newer protocol with better security to the back end. Right? It kind of deals with the fact that we don't have to worry about IP capability. It could be wired devices or Bluetooth or who knows what. So you have this kind of a model, and then therefore really the sophisticated client software is really the gateway. The top end is kind of more the future breed Internet of Things devices that would be IP capable, right out of the box, talk to cloud directly, don't need a gateway almost. I'll come back to that. And then we have this part in the middle, which has kind of a cloud-based gateway, and it has a protocol here that has some limitations of security, so therefore the fact that this is kind of, this has identified this as a weak link, because this may not be acceptable in some environments to take it all the way to the cloud without good security. But this is definitely dealing with kind of the existing install base of infrastructure in an adaptive approach. The back end, and you can get really sophisticated in the back end because to tie into the analytics and everything else, there's all these other types of services that need to be integrated in the life cycle. But this is really all the services you need to have just a managed device side. You need to have something that's dealing with events. And I crossed out this one. This is reliable messaging, and then you need some security mechanisms, authentication and secure connectivity. That's just for this part of the architecture. It's kind of an ugly graphic, but I want to make sure that you had a clear understanding of different models and patterns. And certainly when we get into a specific implementation later, you want to try to understand this. Some of these are hard, some are difficult, and most applications may use multiple models. Okay, so as a security person, I tend to lay out a network and I'll say this part's trusted, this part's not trusted, and then therefore going from most trusted to least trusted. I need these controls, but least trusted to most trusted, I definitely need more. So the notion of trust and these tiers in connectivity actually matter. So I didn't do any overlays here. I'm not sure which part you want to trust. The Internet of Things device that might have been manufactured by some Asia Pac country that we don't know what they put in it, or the back-end cloud service that maybe hasn't been certified as being secure yet. I'm not sure. But the fact is this process in what direction will matter, because how we, whether or not the which end is trusted. So for telemetry, it's the notion that the device is collecting data and it's just feeding the back end, right? For inquiries, it could be, okay, do I need, do I have an update, or it could be cases where, a traffic sign or something like that where it's gonna do a flash if it happens to be some road closing scenario that comes up, but most times it doesn't. So it checks in to see if it has to change its state, but it's primarily kind of living in a given state most of the time. It's just kind of floating away every now and then. Periodically, you have some kind of thing with a command and control. It could be like a software update process. It could be when you're causing the valves to switch and have flows go a whole different direction, navigate for like irrigation or something like that. And the other is notification when the central side, the back-end side needs to push to all these locations. So put that in your head and kind of keep track of, all right, is the device side secure and trusted, or is the back end side secure, and which mode might be the one that I'm most worried about? Okay. Now security. That InfraGuard organization that I talked about last week, Department of Homeland Security, FBI, they care about our national infrastructure. So these are critical infrastructures. And as you go through, I want you to think, all right, this Internet of Things thing, they're creeping into these infrastructures. If they're not done right in that one, are you worried about it? You know, if it's a consumer device and, you know, somebody's playing games with your garage door or something, maybe it doesn't matter. But, so some of these will matter, and therefore what the foundational principles and trusts are will really matter. There are also great opportunities because there's a decent amount of expense to manage a lot of these organizations without this new capability. So the opportunity that the other industries are seeing, you know, they can have here. So the old style SCADA, you know, industrial control systems still required a lot of maintenance, manual maintenance to be able to make it work. The newer paradigm could solve some of that if it's secure. So a little off topic, because this isn't directly an Internet of Things issue, but it shows how current problems are today with what used to be our closed-end networks that should be safe and trusted. Okay? Now we're talking about Internet of Things, it's more of a public networking framework. So I think it's, I believe in lessons learned. It's like things you learn here, you should assume that probably exists in the other place, and then we have to solve that too. So this is as early as September of last year. It's not old time. So it has to do with the fact that attackers can actually manipulate some of these what should have been more isolated networks. Again, they are with a SCADA type of systems, not Internet of Things, but they're certainly controlling some major types of high risk or high dependency energy supplies. And there's a lot of other examples. SACA did a study, and this is kind of just looking at Internet of Things as it relates to business. So there's a lot of different factors here, and I definitely want to have this get into politics, but one part of it might be privacy. So if these are more personalized devices, who's getting to see, you know, how many steps I did today, or, you know, how my heart's beating, or whatever it might be. So there's a privacy relevant item. The fact that this connectivity may end up corrupting my pure security architecture in my corporation. Because now I don't know, I got mobile, I got BYD, you know, I got these things, my buildings, you know, talking to other people and everything else, so my firewall is so porous that it's not useful anymore. That's the threat landscape part. Businesses are having trouble dealing with this new phenomenon. So a lot of companies are not, they're almost like turning a blind eye and saying, yeah, it's really not going on, I'm not going to legislate it, but not enforce it. So the notion is there really isn't sound foundational policy on these devices to make sure they're trusted. So I don't know, you're moving to a new building, and now you're going to end up put all these new devices in it. Sounds like a good idea. Maybe you're going to get efficiency. It's going to be a green building. Are you checking your suppliers and making sure they're following all the right rules, and it's going to be a safe, secure building, or, you know, in green, or not? So it could be procurement processes. It could be, if you're on the side of building this stuff, it could be really on policies on secure development and testing. And then the last piece has to do with return on investment. The graphic slide down here is a little, but on the personal side, there is a decent ROI, but on the business side, it's not as clear of the ROI yet. But I think that's going to be changing very quickly. Because every big business wants big data and big data intelligence. All right, so if we break this thing down, we have endpoints and your devices. We've had endpoint security issues forever. You know, everybody's got a phone. We got some issue there. You got a laptop. You know, so now these Internet of Things devices are your edge points. Those are your endpoints. They got firewalls. Do they have any kind of content monitoring mechanisms? You know, those kind of things. Do they need it? We have this element that has to do with the registration. So if I have a mailbox and I want to be receiving messages, I have to have an address, and the message routing system needs to know how to find me and get me my mail. And I also know how to know where the post offices are to send stuff to have it go to somebody else. So there is this whole notion of the publish, subscribe type of message system. You have the notion of secure messaging within it. In almost all cases today, it's more privacy encryption. There's no content monitoring. So you can have malicious content going through that thing from a rogue device and nobody would know, and hopefully the backend's not going to fall over. Or your big data analytics isn't going to have some very strange data coming out the other end. And then you have this message routing control. It's kind of like the backbone of the mailboxing system. Again, most of those elements are part of security architecture for some time. It's just the fact that this is more of a public domain set of components now, not with a lot of standards and validation processes. Anyone that's really been brought up with security would know that an application isn't as good as the operating system, device level security that it sits on top of. So it all starts with the device. All right, so do we know what the device is? Do we actually know how to register it so it becomes the authorized element within your organization? And then we're managing it to make sure in a life cycle it's kept whole, there isn't rogues. There's some type of method of authenticity to know that's really the device it is and it's coming from reputable source. And some level of authentication, and I want to kind of get into the protocol level, it's more of what's unique about it. Is there some serial number that's unique, something that will make that device that we can validate that's true and it's been authorized, you know. On the software side, the longest time here we've been talking about the world's going to be saved by software as a service. Unfortunately, the security part of software as a service has always been SOAP, and all that overhead on top of these server connections is not something we can support in this thin layered infrastructure. So we definitely have a new set of protocol stacks, and whenever humans create something new, they always make mistakes. First one here is actually very, very new. It's a draft internet ISO standard right now. It's not even going through that full validation process. So it's like a 1.0 ISO standard. The second one is one that's been around longer, but it's unique to this application. So it's more fitting into IoT that's new, but it's definitely something that's been around, and there's a lot more security capabilities and integration capabilities. So before, when I circled the elements that were the weak link, it was the one that was this one. And the one that had, the good protocols, at least it's got some stuff that to work with. The fact is, you have a lot of choices in this. It still might be, weak links, like using a password. So a device has a password that maybe was, password because it came out of the factory, and who's going to change it or whatever. Okay, so for the first one, we have the built-in part of the protocol. We'll support using a password at a device level. So who's going to manage that authentication store on 15 billion devices? Right? So because it isn't some centralized authentication stuff like AD or anything else, it's like a device level thing. So so that's probably fine in an isolated manner, but it's not practical. From an administrative point of view, to make sure this is secure. Okay, knows about password guessing attacks, so there is no sophistication here. And this other part is TLS, which actually is the better answer. So having TLS with certificates, all that stuff's great, but if you track the industry lately, the device level stuff, manufacturer certificates, they're not unique. There's no certificate authority, there's no revocation process, so certificates are being misused. It's like the second layer of security now is violated by the technology people. And so that is only addressed is for certificates, and certificate management can be done as its full life cycle. And there are some capabilities there, but it's not out of the box. On the server side, out in the cloud, you definitely have capabilities where host and IP is going to do that for 50 million or 50 billion IPs. This client identifier is mainly for different kinds of clients, so that may be useful, more of a filter than security. And then it's the authentication credentials. Okay, on the cloud side, with a bunch of devices, you're going to manage them using a password or what? Or are you going to actually have a more full lifecycle certificate management process between the two sides? I haven't seen anybody doing that, but maybe that's coming. Interestingly, the cloud side, remember, there are paradigms where the cloud needs to talk to the device, right? There's a few of those patents we talked about. The device must trust the server. It has no way to know any other way, so there isn't a mechanism inherently in the protocol to authenticate that connection coming in from the server. TLS still is our friend, so if we implemented certificates, you can create that two-way trust. Again, it's a lot of work to manage it. If we're doing, SSL and TLS, we got our data integrity. Otherwise, you got to code it in your app. It's not there as part of the protocol. There's a place to put hashes, but the app has to really play the game and calculate those things. Developers tend not to, you tend to make mistakes. And you don't do code reviews, you're going to miss opportunities. We've got, on the privacy side, application can do custom work and encrypt the content, or TLS will do that more as a wrapper. So TLS is about the only viable option for me to guarantee security through the whole framework for, confidentiality, integrity, as well as authentication kind of things. Otherwise, the protocol really doesn't get you anywhere. The other one does have a lot more capabilities, and it can consume the TLS, so actually it becomes easier to integrate because it's using a mature authentication and security layer that we have been using in other things. It's a gateway strategy, so the gateways can look at this and be able to then gateway to other security-based authentication devices, things like that. So there's definitely the device client side would negotiate the level that it would handle with the gateway server. So this is really gateway if you look at the previous architecture. And then, so therefore, we'll negotiate to some good ones, and there's a lot of different options, right? And again, they can consume the TLS. All right, just about done here. How are we doing? We're not too bad. Okay, so my takeaways, again, just from my quick reading last 2 weeks, putting this stuff together. All right, you start out with the governance part. So there, if you're going to be implementing this as part of the business process, or even as a product and service company offering to clients, you want to understand that risk for you, market reputation, whatever, and also liabilities to your clients. So therefore, start with the risk and make sure you have the right governance framework, the policy to try to enforce it. Might be in the development of this stuff, maybe in the management of it thereafter. Right? Start out with that. Then it's that architecture slide I had wasn't the full architecture for the business process. It's a fairly sophisticated architecture, and it's changing, I don't know, monthly. So you definitely want to understand what's the set of people, third parties and internal, that you're going to work with on that design. And understand that design and take advantage of the right sets of controls. And that, it's not just security, it's making sure that the business value is going to be guaranteed there. So threat modeling is something that's not done enough in this space, and that may identify where your weak links are. Right? We've got the foundation of the device being, clearly identified. We're getting them from right suppliers. We register it, we manage it, and therefore we'll know about rogue devices versus authentic, authorized devices, that kind of thing. And then depending upon whether it is buying these things, like the new protocol stack that's not even an internet standard, there's a number of vendors implementing to that standard, and they're going to have vulnerabilities. It's a brand new architecture, so we have to pay attention to it and make sure we're getting those updates. Make sure you have methods to be able to deploy the updates too, in this new paradigm. And if you're developing, you're one of the vendors here, make sure you have secure development as part of your environment, training and testing and things like that. So that training session on how to do ethical hacking in IoT is probably a good one if you want to help your environment do secure development. Okay, so if anyone wants, I have 3 pages of references, so everything I've got here I've made sure I've documented, so I have all the places. There's some really good resources out there. Again,
can you post these to SlideShare, and that way I can share it with the rest of it?
I'll see what I can do.
We'll find a way to make it little.
There you go. All right, and
that's great.
Okay, and that's me. So, did anybody have any specific questions about the slides or anything that help? Again, we're going to now start to dig into some real life examples as well as particulars on the security realm. Yes?
Yeah, it relates to your takeaways. One thing I was missing there was the supply chain security.
Yeah, no, actually, I mentioned earlier, I didn't include it there. It's a very good one. I could have thrown an example. We've had some, like the Heartbleed and a few other examples when just a normal mainstream IT technology infrastructure, we're not even, the base design of the internet spec was flawed, and then all the downstream manufacturers of that software, we don't even know who built it and then who embedded it and what. So it took, there was one scenario there, it took a half a year for the vendors to identify that they were one of the ones that were vulnerable. So that kind of configuration management issue exists in general in this space, and it's going to get worse here. So looking at suppliers is one thing, but actually being able to know what suppliers are inside the box is the hardest one. Very good point. Anything else? Yes?
I asked about a new technology, and I don't know, it's pretty new, but they seem to be talking about it publicly. So when you have, I'll just ask in general. So when you have a known start point, it's in moving packets, and a known destination. So not just wide open, but over the internet. They are now talking about putting programming around the packet so it will not unencrypt until it hits the known destination as a new security additional to the encryption. So if someone grabs the packet, essentially.
I had to think of that as well, that also.
It's much more.
But actually with.
You may want to repeat the question.
Yeah, this particular case, which I'm not familiar with, is more as part
sort of a new
packet transport that the packet's the one that figures out the trust and whether it's being encrypted. And software as a service has had those foundational principles of policy and validation of policy. I haven't seen enough of it, the management of the policy sets for these things to actually have that all. But the spec has all these capabilities, so it's kind of like, it's a great idea, but it can, is it manageable?
That's what I.
Is that packet smart enough to know?
Right.
Because the security guy in the room is still on the fence, one way or the other,
Yeah.
So, anyways, good questions. And there's bound to be more, but we have to get going with the next speaker.
Thank you, Don. That was great. I know for myself as a technology guy, I'm always thinking, well, technology is how you solve all problems, but the thing that you bring up where policy is so important and checking manufacturers and things like that, which me as a techno nerd, I don't worry about as much. So we're going to hear next from Rahil Khan, and Rahil is here from Verizon. We were lucky that he was here in Waltham for some business because he's from Texas. But Rahil is the managing principal at Verizon of the IoT program there. He's been responsible for the roadmap and the strategic direction of their IoT verticals, smart communities, track and trace, fleet management, energy utilities, IoT security credentialing. So he's taking some of the things that Don was talking about and trying to make them work on a big network with lots and lots of devices on it. I don't know how many devices there are on the Verizon network, but it's more than my home network. So without further ado, is it? Yep, you're hooked up. Okay, good. All right, so here's Rahil. And you have a choice to use this. You can use this if you like it longer, or
I think this is fine.
okay.
Yeah. Right. My name is Rahil Khan. I've been in telecom and security industry for about 20 plus years. Worked with the Department of Defense and DARPA for a while, and on a couple of special projects that I can't talk about, but then others that I can talk about. And also worked with.
Can't hear you.
Okay, can you hear me? Yeah. Thank you. So, yeah, and then basically started back in wireless in Sweden, working with a company called Ericsson, doing research with Ericsson Research, working early on with the GSM world, CDMA, and Ericsson did an acquisition, and then basically working in security industry for when the first standard for third generation partnership 3GPP came along for the UMTS, what we widely known as WCDMA. I was one part of that with one of our ITF chairman, Yara Yarko. I supported him as a system engineer and wrote some specs with him. Then I moved on to customer side and basically working in the CTO group and doing a lot of innovations toward the Department of Defense in wireless, UAV, IPTV, and then working with some of the agencies in both security realm, media realm, and also we're sitting in the motion imagery standards board for Department of Defense and writing some of the specs. So that's basically on, and then moved to solution sales eventually, and started working with the customer pain points. And 2 years ago, I took another R&D job down in New York and worked with the mobile satellite, maritime security challenges, and IoT aspect for refrigeration container devices on several thousand ships that were moving, and they're all connected through wireless, 2G, 3G, now LTE, and satellite, and taking all the data and also doing speed variance feedback for data analytics, which basically guide those ships how to change their speeds online, basically providing them feedback on that, and then also checking on how long it will take for them to reach to a destination or a shore, that all the perishables in those 283,000 containers can be sustained, and then it also will plan data analytics for, after getting to the shore, how long it will take for them to do a destination. So basically taking that into a supply chain ERP model, and then putting that together with the secure connectivity that can basically go on. So those are the practical aspects, and just joined recently Verizon and working on several initiatives for IoT in broader terms, and then also taking on security of things or security credentialing as a piece, which is one of our facilities here in Waltham. A lot of intelligent folks are working on those areas. So with that, and of course I have limited capability to talk about things, so you have to, forbid me for that. So I will just take a general approach first, basically what is the difference between current IT model security versus an IoT? And if you look at it from the broader perspective, there is none, and the reason is that, basically what happens is in IoT, in our IT security models, you have this perimeter-based, security. You do routine updates and patches, which, Microsoft does a lot of that. It's only address cybersecurity issues in some cases. Now, as you have this new mix of sensor grids, laid out everywhere, and then you want to access those devices through, through a patch, which is basically a wireless connectivity, ZigBee, 802.15.4, or a low pan, and then basically you want to have that information transported to a specific protocol, COP or MQTT or additional protocol, and then transfer it and publish it on a web in an XML form, or different other HTTP form, and then you can have that information also stored for analytics at a later point. So basically, that's one of the predictive analytics, and then basically you also do you also have to cater to the security of each device. So there are two types of devices. There are sensor grids and actuators, and there is also the gateways. So you have to secure the path between the sensor grids actuators to the gateway, and then you have the traditional DTLS type security from then on to the internet. And then of course you have to do device identification and management, and that's a big challenge in IoT, because what happens if you have, and I have some practical example from maritime, you upgrade a device or you change the device. You have these device identifications. There was RFID before, we used to do that with that. Then you have the device label registration. So basically what you do, you define a list in a database, and then basically you collect that information and you correlate it with the device. So if a new device is being published, is being laid out there, then basically what you have to do, you have to get a correlation with that. If an upgrade is done on a rogue basis, which doesn't happen in maritime but can happen in a real world, in commercial world, then you don't know if the device is genuine or you have a device that is basically a rogue device. So having said that, there is a framework around it, and the framework is basically you have this IoT security ecosystem today, which has three key aspects. One is the operational value, where you want to present, monitor, configure, and control that. And then you have the key use cases, which is you have that unified model with the presentation, developing your own IoT solution using applications. And I'll talk about that ThinkSpace. That is one of the Verizon's initiative, and then we will bring to the market. It's actually available on public, but I'll have some subtleties there. And then you have this IoT developer community, which basically is similar to how we did Apache and those things. Basically, what you will do is you will develop this framework where developers will have their own applications or APIs developed for different devices, and then work with the operators and vendors, to basically, connect those devices or applications and create, have some innovation there. And then basically those IoT devices can function in a cohesive manner. Now the biggest challenge would be that who is basically managing the security layer on those? The APIs don't. Now you have to have a security management framework or governance on top of that. So basically that Then you have to check for the isolation segmentation of your information, and then you again have to have a multi-tenant privacy. And rate plan doesn't apply here, but this is something we do. And then you have an aggregation model. And then of course you have the IoT connectivity with product as a service app or an application. And then you develop trust and privacy for data and devices, and then you do in-depth, it has to be agnostic over the top of defense in depth. Now the security beyond IoT connectivity is as you go into PaaS applications, is to have a security model which is from the sensor grid all the way to the cloud. And you manage that security, end-to-end security, between the applications that are being developed at the edge, which is sitting either at the gateway or a group of sensors, which is a mesh sensor, and then that application talks to the applications in the cloud, and then you have to have an end-to-end tunnel security between those two. Now, there are different levels of security, and I'll talk about that, basically, that you do at the physical layer and the MAC, and then the transport layer, and I'll give you quick examples and more rudimentary examples, and then go over that. And then, of course, you have this, updates that needs to be done, and then can be transported to, or those updates are going to the sensor grids, the gateways, and then you manage those, So basically, one of the things that we are doing is called ThinkSpace, and if you go to Verizon.com, you will see that, capability. And ThinkSpace is basically an API framework development model. We have hundreds of devices and gateways that can be programmed. We have many users, and eventually we'll open up. And this is a statement I can't make, but eventually we'll open up this ThinkSpace to developers, so that we have a broader spectrum of innovation on that. And that can basically, you can develop different applications using sensor grids, gateways, and those applications could be for manufacturing, for plants, for agriculture, and those applications can be connected to a cloud or a set of clouds. It can be Amazon, it could be Verizon cloud, it could be AT&T cloud, it doesn't matter. And then you can have those machine-to-machine connectivity and applications running with different aspects to just have the farm health of the cows in a farm, Fitbits and those kind of things as well. And then of course the key thing as you have this is the overarching piece would be, okay, there is a wireless mobile private network. Now eventually this private network is not the solution, because eventually you have to have all these devices will be connected via internet. It cannot be for private networks, all of it. In some cases you will. In DoD's case, it will be the case. In a commercial world, it will, is rapidly changing. So then you need a framework, and that framework is basically IoT security credentialing, where you will define all the aspects of different layers of security as we go along. And then of course, this is, I'm going to go over pretty quickly, but this is just about theory, that okay, how the framework will be summarized. You'll have alerting and logging, you'll have communication, you'll have physical security, you'll have authentication, cryptography, and then the platform security, which could be sensors, which could be gateways, which could be a core platform that is managing all the IoT devices, which connects to mobile network, which connects to enterprise network, depending on what your application is. This is a pretty busy slide. This is just a concept that I wanted to, basically end-to-end concept that I wanted to just, and this is something, it's in the books, so it's not exactly what Verizon does. Everybody does this thing, and I'm just going to go over certain things that we are doing. And you have different applications for manufacturing. You have sensors, you have microcontrollers, actuators, and then you have the gateways. And these could be a Wi-Fi gateway, it could be 802.4, it could be all these connectivity mediums, and it could be satellite in some cases, like in maritime. And then of course you can have different protocols. You can publish in XML format, you can publish in HTTP format, or you can just use those protocols to publish the application's information. Then you of course manage the security, which is the key, and there are different flavors to it. You have the governance, you have the threat management, you have authentication and privacy, and then you have the professional security services if you have anything which is not vanilla. And then of course you have the security for the device attestation, and that basically is managed through provisioning or device management. ThingSpace is again an application model. A lot of other vendors are developing it too. We are actually working on it, and we have hundreds of devices already being programmed with that, and eventually we'll go forward and see how we can open that. Then of course the cloud architecture, where you will have your analytics, you will have your big data model, you will have all the data ingested, and then you will do some post data analysis, and then after the post data analysis you will do feedback, and you can also do what's next, basically, and that is the next big thing, that you will manage your devices. You will also look at if there is any rogue devices and those kind of things. And then of course, as we were talking about, then we can also look at the supply chain management. The key aspect in all these is another aspect, is supply chain management security, because supply chain management in manufacturing and industrial automation would be a key factor, where you will transport a lot of information that would be handled by supply chain managers, and they will make decisions on it. It could be post decision, or it could be a decision which is online, and that decision could be eventually mapped to a model or a theoretical model where you won't have a human intervention, and basically the feedback would be based on analysis based on their data, and that data will decide what next steps needs to be taken for supply chain management based on the rule engines or correlations, if you will. And one of the companies I was working with in Belgium, it does that a lot, not with Verizon, but another previous company. So they do all that rule-based engine where they do correlation for IoT, and then they are actually working on frameworks where they can do real-time analysis and then make decisions, feedback decisions, not without human interventions. Of course, that is still not refined, but that would be another approach. Now, but when you're doing that, if somebody hacks that system, then you have this rogue, element that can take over that. So that's another aspect that we are looking at. This is more of of a generic slide. What is needed for security credentialing? We need data needs to be gathered, processed, filtered, and transmitted by terminal or any connected devices. Could be a sensor, could be a gateway. Then it's passed over any transport connectivity, which could be any of the radios, satellite, or fixed line. Then basically information from across your IoT devices is gathered, stored, and often it's in the cloud, and you do analytics on that, and basically depending on your sophistication of analytics, you can model your system, how you use it, and for vulnerability and then other things as well. And based on these insights and are sent to enterprise and systems, you can make actionable data, and then that data can be monetized for business purposes. At the same time, that data can be used for security as well. And then of course, this is just information, and it's published in Gartner as well, that brand damage, lawsuits, and legal fees, and this is as Don talked about it. The cost of data breach in U.S. is about $230 per compromised record, so that's fairly hefty and expensive. And just think about it, that it is $3.8 million in breach as we grow these networks. Imagine the amount of breaches can happen if we don't have a great security model, and then we can we have to seriously look at that part. And then of course, as things require new security model, there'll be people in the academia who will, dictate that, and we will, and in standards. And this is just a framework to how, and these are all open published things, that how IoT devices and things can do intrusion prevention, firewall, and VPN. Most of these are standard security models that are today established for IT and other areas, for mobile networks, or even fixed line networks. And we are actually pretty much using those. But as we spread the sensor grids around us, we have to think back and see what is needed. As one of the questions came out about, and I will talk about it a little bit, and I was working with that, is information-centric networking, which is one of the RFCs. And there was a driver for that, okay, when the data is only secured when it is transferred from point A to point B, and if it is video, audio, or data, it will be defined between the two peers, not between a host and a server. That concept is coming, and as that concept takes on or prevails, that will actually be very interesting for IoT sensors, because that would be where you can transmit video from a surveillance video piece from one video location to just another peer, but not to the host. And that needs to be secure between those two endpoints. And then, of course, these are like the standard, techniques that we use. I'll go fairly quickly over this. This is just basic theory. We all pretty much have gone through it. Certificates, what do you provide? We have authentication, data integrity, confidentiality, non-repudiation. These are the things that we use today, and these are the things we are using for even IoT, with the DTLS as well. And then these are basically, how do you confirm? This is an example. If you have, TLS, you'll have HTTPS with that, SSL protocols. You use DTLS for, application on top of COAP protocol, and then you have different encryption method. You can have message authentication code algorithm as well to do that. And this is just, creating a flow for that, and how you can have a secure connection for a standard, web-based system, and it will be devices as well. So you can have a IoT device or a gateway with an antenna right there with Wi-Fi or low pan or 802.15.4, and then basically you do the same model here, and then you have the MDM and UDM for unified data management that you can do it through a big database, and then you do the simple certificate enrollment, or you can do a batch model where you have hundreds of thousands of sensors grids, and then you run a batch, instead of doing a certificate for each device, and that's something we have done in Maritime as well, This is, so what is IoT security credentialing? The concept is a three-layer protection. It's not an unknown fact. Application protection, which adds over the top layer of security, which is going to be DTLS in this case of IoT. Trusted authentication, that's only approved devices or people access, Apple devices, and then data privacy, which can use, encryption, standard encryptions. And then, of course, with the mobile private network and IoT, it won't last long because we have to have a better mechanism than mobile private network or a private network. You can have privatize the data path, prevent outside access, but that can only happen for certain industries. As we throw these devices on internet, and it will happen eventually, and each one of us, or many of us become developers, that poses a challenge. And then now you have this different devices that are changing, there are upgrades and updates, and how do you manage the security, how the device identity is managed by, common database, as we do and then basically take action on that. If there is any vulnerability, how do you manage that? How do you test that? And those kind of things. This is more of a detailed model for each layer from physical to application. I think Don has that in his some parts of it, and then it basically, okay, here's the OSI model, here's my API functionality, at application layer, what can I do, and then all those other layers, starting from network infrastructure, and then, basically you pretty much, nothing has changed so far in the security domain, except for some of the protocols on the connectivity side. And then, of course, if you do a security threat analysis for IoT, there are certain elements that we are actually looking at, which is similar. All those, things, cloning of IoT device, that's a big challenge actually. Cloning of IoT device could be rogue devices, updates, upgrades, and those things can happen. And then this is basically, another flavor of that with a lot of RFCs that you can go look at and basically have a little deeper, way of how things are done in that regard. And then, of course, what is the target? The target is unsure of who will have VM devices. It could be retail manufacturing. It could be, eventually, campuses. And then, are these devices or the system is security aware? And basically, what we want is more than a private network. And as customers and consumers, they do get it. And then if they don't get it, is it worth it? Basically, a lot of customers are looking at how much I want to invest, like for supply chain management, how much I want to invest in my security for IoT. Is it worth it, or should I just have a supply chain manager who can look at it through some kind of software tools and ERP, and then just have an IT framework that is security framework that is already there. So that part is still not solved in many other areas as well. This is more of what we are doing today, and we are looking into a lot of solutions for smart communities, and we are connecting millions of devices. As a matter of fact, officially, if you look at 10 million devices, and I'm heading that right now, that has been connected, and we are going more in different areas, smart communities, smart cities, and smart traffic, intelligent video, and then they're all coming together. And ThinkSpace, as I mentioned, basically would be an application portal where you can develop applications. It's fairly simple. You can have, different, you can have events. Basically, you can develop application for vehicle parking and for water main leak, and those, you alert and adapt, you write that application, you publish using an XML or any other PostScript language, and then you basically just store it in the data, and then you can use some analytics tools to analyze that and take action on it. It could be an action which is proactive, it could be reactive, depending on how you define those correlation engine rules. And that basically we will, as you see from left to right, we have different devices. It could be LTE phone, it could be a 5G phone, it could be a device, it could be a gateway, it could be a sensor, and that connects to a traditional network. And then you can define your rules on that ThinkSpace core and connect those applications. That developers can do that and work and collaborate with us, and then those APIs can be used for connecting to the sensor. We also do a management of security there, and device management and security management as well. And these are use cases. There are several use cases, and I'm not going to go over these, but as Don and I talked about it before, there's payment card processing issues where security is an issue. In the health, because of HIPAA and others, there are issues there. For IoT security credentialing in mobile devices, there is a business challenge now that the operators have opened up bring your own device, and forget about operators. In Pentagon, and this was the news, they have opened bring your own device. Now they have basically canned that project because it didn't work well, and because you can have your own personal and dual mode sites. So the challenge with that is, how do you manage it? It's very, very cumbersome, you know. And then, on top of that, imagine those devices that are not managed by humans but by machine, which is more effective most of the time, but, you know, and when it goes wrong, then there is no control, and it's beyond control. And then, of course, the benefits of, as we see it in future, as we move along, that, as we have secure machine-to-machine sensor connectivity, one of the things is going to happen is, with the secure network, it will be less error-prone. In an ideal world, machines are less error-prone when they're acting on their own behalf and we have programmed them right? So basically, that's where we are heading, with the security. And then, of course, I would like to conclude, with a couple of things. There is a challenge for mapping the IT, current IETF and 3GPP. 3GPP2 is almost gone. Security to the machine-to-machine and IoT security as we grow these networks. The other thing that I talked about is the paradigm that is coming up is the information centric networking, which is the RFC 7477, and there are 3 more RFCs there, which will have this end-to-end data encryption, and where you can have a datagram talking to a datagram peer-to-peer basis, no host, and how we will manage that. And how will we can manage that in a private network. That's great. How it is transposed between multiple networks, and the datagram that can be actionable data or useful data for for an operator or a vendor or for consumer, how you will use that, and that might be a video between social media and collecting some data from sensors and then sending it to another human, and then basically looking at that between the peer-to-peer without a host. So that's another concept emerging. Then, of course, the bigger things at the post side of the cloud is, how do you define the correlation for rule-based engines which can do trending to minimize security breaches? Take the data and do analytics on that at that very moment, and see and correlate it with the different trending models and check if there is a security breach based on the previous behavior. That prediction model is basically is another interesting aspect that might be coming along. And then, of course, the biggest challenge is in DoD and commercial space, is how do we manage these sensor grids and devices and applications, which are millions and millions of devices connected through homes and commercial, residential, on the smart traffic level, and then actually to the point where public safety becomes a big issue as well, where you have these sensor grids for public safety, and also connecting it to citizens, and then having that data to create functional security for human society, and basically have a secure model for IoT security. And with that, I'll end my presentation.
Anyone questions? One thing I was wondering as I was thinking about it was, as the devices, are spread out, are you going to need hardware in the device to manage the security, or is software going to suffice? Are there going to have to be special things in the microcontrollers to?
Ideally, basically, in some cases we do have, crypto hardware, right? And some of those, DoD still does a lot of hardware-based security, and that's a challenge. You see those RSA Motorola phone, it has a security chip in it, and that basically is what most of the commercial industry is leaning away from that. As the processing powers will increase, I do see that, or I do envision that it will become an application-intensive, security model, as opposed to the hardware or the chip-based security, which a lot of Qualcomm is doing in some cases, and Motorola is doing, and so that will change. Now that also changes with the sensor grids and the gateways. because the gateways are, of course, there is a microcontroller there, but the gateways are defining a new paradigm where you can have, and actually they are looking at it, of course, on that you can have an application level of security, after the authentication, can you have that? So I think that model is still, and then we have to see how sustainable it is, how fast it is in terms of processing, and I'm not worried about that as the processing is going, getting better every day, so that might be, my take on that.
Any other questions?
Yeah, but just a quick question. It's sort of related to, I guess, security, but it's more on the connectivity methods.
Sure.
My friend recently texted me about Wi-Fi. Could you tell me more about Wi-Fi, how it compares to Wi-Fi now, and any current use cases for it? Or
yeah, so Wi-Fi is definitely still an efficient tool for connecting. We did some of that in our maritime solution. The only advantage with LoWPAN is basically one is, of course, is power constraints. Is going to be a challenge as you increase the devices. That's one of the key issues. And then, of course, the other thing that they're working on is on the LoWPAN side is the security models for the ITF. ITF is very active, and they're working on the newer security models. So that's basically, as far as from the connectivity level, the quality of connectivity, I don't see any issues versus between Wi-Fi versus LoWPAN. Yeah. Go ahead.
I just have one quick one. So I've been talking with a lot of people about starting to put the bio stuff on the actual phones now, with eye scans and prints, and I've seen some of it, but it's not well done. And so I wondered if there was any work on that with Verizon. Do you have any level of focus on sort of that kind of authentication, which people are starting to feel?
I can't speak for Verizon on that.
Could you repeat
Yeah.
the question, please?
Yes.
For authentication using eye scans and prints and more biogenetics rather than passwords and designs and that kind of thing.
There is a lot of industry leaders in that, and as you know, we are an operator. We work with a lot of industry leaders, so we keep an eye on things going forward. There's a lot of companies I'm aware of that they are working in that area. So far, nothing has, as you said, nothing has materialized.
Right.
You do have a thumb scan, in an iPhone or Android, but that's pretty much it. And the quality of those is improving every day.
Okay.
So what's going to happen next? We basically there is a lot of companies in Silicon Valley that I'm aware of. They're working on those areas, and it's just that those products are not being either mature enough at this point, or there is a paradigm shift that operators need. We have big vehicles and they move very slowly. So I think that's also another part.
Okay.
Yes.
Yeah, you talked about credentialing, right, and being able to authenticate the endpoints, and specifically sensors.
Yes.
How is that done today? How are people getting certificates and keys to the sensor? Is it through the batch process that you mentioned? And if so, what is that process look like? How long does that take? I'm trying to understand how you authenticate a sensor with the initial provisioning and then management of those certificates.
Yeah, so basically what you do is, you have the gateways, right,
So
connecting
could you
those.
repeat the question again so we can all hear it, please?
I don't know if
I can do it justice word for word, but the general sense of the question was, how do you do the credentialing, the initial provisioning of the certificates and the keys to the endpoint of the sensor? How do you actually put that on the sensor initially, and then how do you manage those certificates and keys over time?
Right. So one mechanism is, of course, that each sensor set or a sensor, group of sensors is always connected to a gateway, and gateway is usually, of course, there is a chip there and there's a microcontroller in the gateway, and then basically you can have, and this is not ingrained and done every day, but then I can tell you about one of the projects that we did when I was working for a previous company where we have this onboard computer on the maritime ships, and that has a storage capability. And what we do is we push out those certificates on that particular computer, and it has certain batch programs written by some of the engineers I work with, and then what it does is basically it will push those to each device or set of devices, and then collect the data for the certification, and then once that is done, and this is unique, it's not a standard technique, and then it will pass it toward the connectivity layer, and then we store that. So that's one way to do it. The other more sophisticated way would be is basically a direct connectivity to those batch. But then what happens is these sensors are very cheap. They're like 5 cents to 50 cents a piece, and depending on what you're using it for. But if you're putting it on a truck that is rolling and has fleet management, they're very cheap, So basically, putting that more processing power or the capability may not be possible today, but maybe in future. But that's something maybe you can write a patent on. But that's something So. Yes.
Quick question. Can you say who makes the sensors in that last example? Who's the supplier of the sensors?
There are many vendors, for different things, right? So if you go out there for traffic, Census is a company. If you go for a dual mode device management and provisioning, out of California, there's a company called Caliam. They do, Caliam, actually California Amplifier. That's the, so there's a lot of those companies out there. You can just go search on internet, and as soon as you do that, you'll have a list of those.
Well, thank you. So we've got one more speaker tonight. I'm just wondering whether do we need a 2-minute bio break in between the two? All opposed, yay, nay? Nay, keep going, okay. Okay. So our next speaker is Harry Schechter, and Harry is a local entrepreneur, kind of a serial entrepreneur, and his latest company is called Tempalert, and what they're doing is they are a practical implementation of a lot of these concepts here. They're measuring temperatures of pharmaceutical and retail type companies, and they're recording that data, uploading it to the cloud, using the Verizon interface to do that. So Harry's also a kind of an interesting guy who's been nominated for a Grammy, but I haven't heard that whole story yet.
There'll be no singing tonight.
So if you need him to sing afterwards, you can. Anyway, without further ado, Harry is here, and he's the CEO of Tempalert.
Thank you, Jeff. And thanks for inviting me this evening. Boy, Donald and Raheel are a very tough act to follow. But I do want to say, I want to tip my hat to Raheel and Verizon. They are a very close partner of ours and have enabled a good majority of our business. So we appreciate that and look forward to continuing. So I thought this evening, I took some notes as we were listening to the other presentations to try to come back to some of the things about programming certificates and security in the supply chain, for instance. And I thought I would share a little bit with you first about the company, give you a little overview of the solution and the type of customers that we serve, and then focus mainly on the experiences we've had in securing IoT, and really drill into things that customers have said and asked us for, and what we've learned along the way. So please feel free to interrupt me anytime during the presentation, as well as ask questions at the end. So Temperature Alert, I like to think of us as Boston's oldest startup. We're about 11 years old, but it still feels like the priorities change on an hourly basis, and there are never enough hours in the day. We were founded out of MIT by a group here in 2005, and our goal is to transform the way that organizations sense and use data, and then ultimately make business decisions with that data. No longer is it, hey, it's too hot, it's too cold, it's which one of these refrigerators is performing the best? Fantastic. That's a question we got from an actual customer who went, turned around, told them, and they bought $15 million of those refrigerators. And so our strategy has been to optimize our systems, not only for efficient deployment, but for team collaboration. So when there is a problem, it's not the responsibility of just a single person, but a group can come together. one of the major pharmacy retailers in the country has 80 people managing a monitoring center where they get 8 million alerts a year. 8 million alerts a year from their refrigerators in front of their stores holding food. Only 1 million of those alerts are actual real problems. It's incredible. So we want to cut that down. We want to show folks and our customers that we can get you only the real alerts. We've been doing this particular hardware platform since about 2008. It's the 7th generation of the hardware. I'll show you some pictures in a minute. It's very well battle tested, and we're in 75 countries around the world. And then for every system that we sell here, we donate a system to developing countries overseas that are on the UN and UNICEF special list for developing nations. We work with the Gates Foundation and the Clinton World Global Health Initiative to get those out there. So currently we're automating monitoring, the remote monitoring of mostly temperature at over 50,000 locations around the world. By the end of this year, we'll be installed in over 25% of the US pharmacy market. And it's incredible. I've never seen anything like this in my career, where you have organizations where, my competition right now is a pen and a clipboard. They're paying the pharmacist to check the temperature every 6 hours. And the organizations are now either in the process of considering IoT or rolling it out. And they're falling like dominoes. It almost feels like a land grab right now with what's going on. And we service a number of other industries that include food, transportation, industrial gases, and some technology. And I'm going to skip around a little bit here and show you the actual solution. Most of what we do is in the pharmacy space. So we'll connect to stationary devices, whether that's lab equipment. And I always like to say if it shakes, moves, or wiggles, we can monitor it. Actually, it's got to produce voltage, but it's the same thing. Fixed assets like refrigerators and freezers, equipment, we can do belt speed, everything outdoors, wind speed, rainfall, refrigeration monitoring, and then recently we've added a new dimension to everything, which is movement. So we can do smaller totes and coolers with different wireless technologies all blending together in the cloud. So here's the main system, then I can go into some more examples. So this isn't just a temperature show. So we have a cellular or a Wi-Fi gateway, and you can connect wired sensors or wireless temperature sensors to this gateway. It will gather sensor data and send it up to our cloud. Now, we originally got our start in 2005 in the IT space, selling USB thermometers. And I love the IT space because the customers are very technical, they're very forgiving, and so we could send these USB thermometers out to people, and if there were problems, we could just email them a software patch, or they would figure out what the SMTP server is, or the Wi-Fi security. And it was wonderful, it was brilliant, because at the time we had a website selling this stuff, and it's amazing what happens when you put a phone number on the web and throw some advertising at it. You get all kinds of crazy people calling you. Can I monitor my pet in my RV? Yeah, sure, but it's only on for 3 months out of the year. That doesn't feel like a good business model. I remember before 2008, we were selling USB, we were selling the Wi-Fi edition, and people would buy it, they'd go install it, and then we rarely heard from them again unless there was a problem. Now I remember being on one installation, and this was right at the crux of when we exploded into IoT, before it was named IoT. We're very grateful to have someone much more creative than I who came up with that name, but there was a hospital system in Western New York that bought 50 of our Wi-Fis. And I remember going, because this was back when it was maybe me and 2 other people, to do the installations. So it was me, then there was the IT manager to get this device on the Wi-Fi network. There was the facilities manager to drill a hole in the refrigerator or in the sensor. There was the local nurses station representative to make sure we weren't messing up the stuff in the fridge. And then there was the overall project sponsor. There were 5 people going around to every fridge. And it just, it made my week because I had this great sale, and it ruined my week because I had this great sale. And after that, we came back, instead of allowing customers to call us and pull us into these other markets, we said, enough, there's got to be a better way. And designed the cellular version of this gateway so that you could send it out to anybody. Anybody, the person you sold it to could install it. All they have to do is plug it into the wall, and it turns itself on. It's already pre-provisioned. It starts sending the readings that it's taking over its built-in cell phone, Verizon cell phone modem, up to our cloud system. where the data would be processed for alerts. And this was a game changer for us, not only because it was so simple to install, but we started generating recurring revenue. And that's what allowed us to really fund growth and transform the business. But in doing so, I wish I could be up here and say in hindsight that we had the brilliant foresight that this was going to happen. But when we started selling this, for the longest time we were an e-commerce company selling direct to consumers, and realized that we just couldn't get past a certain level. So we changed our shift to enterprise, and boy was that hard. Right? The scale is completely different. The security requirements are completely different. And we had fooled ourselves with the first big customer. We fooled ourselves. We showed them the system, and they said to us, "Wait a second. You mean you have your own power? You have your own battery backup in this stuff? Yeah. You have your own cell phone in this? Yeah, that's right. So you're not connected to our internal network at all? Nope. You don't see any of our patient health data? Nope. You don't see any of our credit card data? This is a retail pharmacy? Nope. So that's great. Perfect. That's what we want." So in making it as simple as possible, we actually had a security play here, in that we were completely separate. And this was right around the same time that Home Depot had their credit card hacking exposure. And so this was all over the news, and all of these pharmacy retailers were just terribly frightened of anything going on the network. But it was, we lulled into a false sense of security. As you can see from the other two presenters, there's so much more. And I remember going through a security audit. They put us through a security audit. The first thing they did was they sent the cellular unit to their IT group, and they said, "We can't connect to this. There's no Ethernet for it." We said, "Exactly. Are we done?" I said, No. We were far from done. And we met them in the store, and we installed everything, and the security expert, who was mind-blowingly good, had this Android tablet with an 802.15.4 sniffer, because we were running Zigbee, and just immediately started rattling off all these things. Well, you need to run certificates, you need to run encryption. I can see your network key. What is it? I can't show it to you. What do you mean you can't show it to me? Let me make sure that it's the real one. Nope, that would be unethical. So, yeah, but we like to think we can do the impossible, or we fool ourselves into thinking so we got a shot. And we went back, and they said, the first thing they said was we needed certificates. Well, at the time, running Zigbee, there really was no great implementation that we could use. The best option we had, how many folks here have heard of ambient devices? Pritesh and David Rose. Anyway, so these guys, I happened to meet them at another event, and they took this problem to them because there was no good solution. And Pritesh said, "Oh, you got to call, you got to talk to this guy at Signal Fire or Silicon Labs." And I talked to him for a while, and he said, "Yeah, you can do certificates, but it's got to be a certified smart energy meter, and you got to get the certificates from Certicom up in California, owned by BlackBerry." And so we called them up, and they said, "No, this is for smart energy meters." And several conversations later, and a lot more money later that we were able to get our customer paid for, we convinced them that the IoT landscape needed digital certificates on these types of end devices. And so we got those installed, we went back, we changed nothing else, and we passed all the security tests. We'd already put AES 128-bit encryption on the Zigbee signal. They didn't even look at the cloud side of things, which I thought was astounding. I remember one person in the room saying, "Well, it's just temperature data." But then we have another customer who completely ignored this side of the equation and focused exclusively on the data flowing through the carriers and in the cloud. And this is a company that makes rockets. So they use our temperature sensors to monitor the curing rooms with the adhesives on the rockets so they know that they're the right temperature. And their main concern is that a rogue state would intercept the data, change it, and then allow it to get to our database. And we have encryption, we have, on the Zigbee side, we were using, I think, SSL to get it from the cellular gateway up to the cloud, and that set off all kinds of alarms. No, it had TLS 1.2. And so we immediately switched that. and that made them happy. But it just felt very reactive, and so we started being a little more proactive about this stuff. The first thing we did was we just started meeting regularly as a group, looking at everything. I mean, every aspect of the business. What's the lock like on the front door? What if someone walks in and tries to do something? I have bear spray in my office now because of this meeting. But yeah, don't want any weapons in there, but at least who knows. But my point is that no task was too small to uncover, and we continually do this meeting every week. Every week we have it, and it always uncovers something. It always uncovers something that we need to address. And one of the other things that I found really interesting, I love this community because it's so small. DARPA down the street here is working. They approached us and said, "Hey, can you collaborate with us on a new inherently secure processor where you cannot do buffer overflows. You cannot piece together bits of code and execute them maliciously on the processor." It's brilliant. It's still in its early phases, but if you go to the website, you can look up the inherently secure processor. Something that I think is going to be more and more important outside of DoD as we look to customers where these things may be mounted in a refrigerator and anyone can go touch it. If they open it up, if they start connecting to pins, you can do some real damage on other systems like that. So, just going to skip ahead here to the cloud side of things and the analytics. One of the things that really sets this system apart is we're continually aggregating data about how it's operating. With every, a temperature reading is maybe 4 or 5 bytes, but with every reading, we're sending 50 to 100 different parameters on the performance of that network. What's the signals quality? What's the link quality? How many reach heights? How many nodes are connected to a gateway? And the amount of data that's generated from just the sensors is one thing, but there's 1,000 times more metadata around all of this that we still, I think we do a good job analyzing it and are able to predict when something is having trouble or about to flatline, but there is just so much that can be done with this data. And we worry sometimes that some of the debug information gets into the wrong hands by people accessing the cloud. And the other trends, we see wildly varying education out there with our customers. Some are really together, they're really with it, they know exactly what they're doing, and others are, investigating our system and say, "Hey, I'm at the shell prompt in the gateway." I think, what shell prompt? This is an 8-bit Atmel with a control loop. There's no shell prompt. What is that? And we've pulled our hair out of this, and it turns out they were looped back into their own tablet. I want that week of my life back. And even today, I was at a drug manufacturer in Western Mass, who remain nameless, wonderfully successful manufacturer. And there's one person in the room saying, "We can't have the data leaving the building. There's no cloud whatsoever. Absolutely not. It's got to stay here. You've got to find a solution and keep it here." And then there's another person in the building in charge of the building automation systems. "Oh, we send data out all the time. Human resources data, that's all in the cloud, and that's very personal data to each of us. They send sensor data out already." And so the disconnect between the policies is astounding. And we often joke that we have one customer in the industrial gas space where we've been working with them for 2 years on some projects. You just got to live long enough to see the end of some of this stuff, to help the organizations change, not just the business case to afford it, but the policies that govern their security practices are significantly aligned against IoT in the cloud, at least in some of these big ones. So I wanted to jump also to the question about the supply chain. We struggle with this a lot. We struggle a lot because in order to build efficiently and effectively, we've had to go overseas. And so how do you find that trusted partner? Luckily, we were able to use a referral, but who has control over the certificates at what point in the chain? We've spent a lot of time over factory, where they actually are programming the certificates. That we actually have one of our folks there almost all the time when we're doing the programming to make sure, the certificates are from us. We would know otherwise, but that they're not compromised in any way. Even putting our own programming on the microcontroller, I still feel like we could do something better there, because the code is locked. But if you don't have a trusted manufacturing partner, could somebody take that locked code off or clone the chip or something and start messing with your systems? And so back to that point from some of the earlier presenters of, how do you know what devices are on your network, that they're yours, and what do you do, how do you detect that data? And especially now with trying to figure out the analytics, there's this giant sucking sound that now the GE is moving to town, with all the data scientists are disappearing quickly. And so we're hiring as fast as we can in engineering, and it's mind-blowing what we're seeing there. And then there's, I think, the biggest problem, which is the humans. If we just get rid of all the humans, I think we'd be in much better shape, because it's one thing to send somebody 100,000 sensors and be done. It's another thing to actually get them deployed into 100,000 refrigerators and successfully working. And 6-7 years ago, we were maybe onboarding 150 new customers a month. And this year, our peak installation will do close to 300 a day, 300 locations a day. And you can only do that with outside installers, maybe third-party contractors. So we have an extensive program to train them, an extensive program to audit their work. And then, over-the-air updates are great, but every once in a while, you get 100,000 sensors deployed in 10,000 locations. A certain percentage of them stop working. Maybe it's from an update, maybe it's because someone smashed it. And so every day, there's just continuously someone calling in, someone verifying they're legitimate and dealing with these sensors. And then we have to send someone who may be new and leave that company the next day in to deal with these things. I mean, it's a nightmare. Talk about certificates and, how do you validate driver's licenses and who's able to get in there. And it's just, when you deal with these large numbers at 1% error rate that you have to touch, it's a big number of, let's say that's 1,000 sensors and they're probably all 1,000 locations. It's $200 to get somebody there. It's insanely expensive. So, in our quest for simplicity, we hide a lot of this stuff from the end user. They don't see any of this stuff, and the smart ones will really dig into it, and they'll really work with us as a good partner, like Verizon does. And I get calls all the time from the reps here, hey, we've got this update, or we need to redo the VPN, or we're making changes. They're very proactive in making the network secure. But I'll tell you one last story, and then we can move on to some questions. And when we were onboarding the first major pharmacy, they said, okay, where's everything hosted? Well, we hosted at Rackspace. They're a good partner. We've got DevOps here. We've got a company that helps us if we're experiencing some major issues. And they said that we can't do that. We don't do business with Rackspace. My contact over there pulled me aside and said, they're dead to us. And I said, oh, okay, well, why don't you do business with Rackspace? Maybe we can learn something here. And he said, can't tell you for legal reasons. And he said, can you move to Amazon? I said, yes, that's no problem. Give me $200,000. Just kind of half joking. And he said, okay, great. It costs a lot more than that. It's like trying to perform open heart transplant on a marathon runner while they're running a marathon. But the engineering team did an outstanding job and didn't miss a beat. It was incredible. So then we were in talks with another major retail pharmacy, and they said, where's everything hosted? So I was very proud of me. I said, Amazon. And they said, we don't do business with Amazon. You have to move to Rackspace. And so, for non-security reasons, well, who knows what the real reasons were, right? But we ended up having to split the architecture and running multiple sites, which, in the end of the day is probably a good thing, right? But we're always constantly battling with, legitimate requests, off-the-wall stuff, and stuff that just isn't even true. And when an enterprise company says, we need it this way, we drop everything and make it happen. Even if it's, not real. But we'll get to the bottom of it. And so I think, the lesson that I've learned here is that it's fantastic to be open and transparent with these partners. And we've learned a lot, and probably, the security audits that they've done would probably have cost us 6 figures had we gone out to the open market to do that. Now, we're in a position now where we can do that regularly and test these systems. But at the time, boy, it was very helpful, very helpful. So I'll leave you with that, and open the floor up to additional questions. For Tumblr, for Harry, for Jeff. Good. Good. Yes.
So, a really interesting presentation, thanks. It's, I think one of the things this raises is sort of the, in the IoT space, not all data is equal, and your company would seem to be a great example of needing to have the conversation around what level of security is appropriate for this type of data. So if the data is merely about temperature of the freezer, for example, is that actionable data for an adversary or not? What are the attack scenarios? So I'd be really interested in kind of how you went through that process internally of saying, so we're not on their network. We've got our own network set up. What are the scenarios that we're looking at here in terms of how this might expose our customer to a damaging attack, or how we might be exposed to a damaging attack?
So that's a fantastic question. Actually came up today, when someone said it's just temperature data. And I hear that all the time.
Right.
And luckily there's a voice of reason in the room. It's usually not me. And they said, well, what happens if someone gets a hold of data that shows we had an excursion where they're storing medicine and publishes something about that? And so I think that you're right? There are different classes of data on the internet, and having that conversation, that kind of conversation with the customer, being completely transparent, is what's propelled us in our momentum, because then we can address it before, all these service contracts we have are 80 pages and they require $15 million of all kinds of terrible insurance that right. If you have to use it, you've got much bigger problems. Right. Right. And so having those conversations about what happens when the data is compromised, what happens if account information is compromised, phone numbers for alerts. Sure. And then that's when the real work begins. Yes.
Do you encounter any regulatory with pharma? So in other words, does FDA want reporting on these numbers?
Yeah. Oh boy, that's a great question. And that's the only reason I'm here tonight. Because of the regulation. In IT, when we're monitoring server rooms, it's nice to have. But in biopharma and food service, milk stinks when it goes bad, a vaccine doesn't. They are required by law to have this stuff. Yeah. But every state is different. The state boards of pharmacy set the policy, and so it's a patchwork right now. Now, the leaders in the industry are rolling it out. The pharmaceutical leaders, the retail pharmacies, the ones, the major ones that you know of and you would go to in this town, all have adopted this stuff. So it's nice to see that. Yeah. Question in the back. Oh, right back to you.
Exercise tonight. Thanks. So in the case of smaller mobile totes and coolers that you mentioned, you have a whole different set of problems with sensors that are damaged, lost, and the cost for something that small. So how do you deal with those issues that came up with that?
Sure. So we were in talks with a hamburger manufacturer in the Midwest, and they complained to us. We rent these data loggers from a company actually based here in Massachusetts, and they send out the data loggers, one in a box of meat, and at the other side they've got to connect them to a computer through the USB and get the data out. And any guesses as to how many actually make it to the computer to get the data out?
30%, 20%.
Spot on, 20%, spot on. And so, can you imagine spending all this money on these things and only getting 20% of the data. It's nuts. And so we look at that and we think there's something that can be done there. And it's in its early stages with us, but I think wireless and IoT is the perfect solution for that, because if you can figure out a way to get that data in real time, you don't care if you lose the data level. Well, you certainly care towards the end, but it usually makes it all the way to the end and then it's lost. And so you can eliminate those gaps and get all the data and get your ROI way up on those data orders. Yes?
How do you build the algorithms that decide what's anomalous and you need to alert somebody?
So the question is, how do you build the algorithms that detect the anomalies and have to alert somebody? So we've adopted Twitter, I think it was Twitter's Lambda architecture, which means the data comes in and it gets split and copied. And on one half, you've got immediate alerts. It's too hot, it's too cold. On the other half, we're looking at the data models over time. So batch processing of the data that takes a lot more, a larger window. And what we have found is that we need many people, much smarter than I, to look at the data, and they use a lot of the standard statistical packages I could find out. I don't remember off the top of my head what they are, but for instance, we can watch the normal cycle of a refrigerator as the compressor goes on and off and ignore that by modeling. So if we have a problem to solve for a customer, we've got to specifically model and investigate that problem almost as a professional services engagement, and then put it into that Lambda architecture.
So they give you the parameters initially in terms of temperature ranges and things like that?
Well, they'll tell us, so there's a dairy in Ireland we're working with, and they want to know when, they want to monitor the milk production from the cows, right, and they want to ignore the sanitization cycle of the equipment. And so, the data science joke that I don't get is they just start off by saying, assume a spherical cow. I don't even get it. But what they'll do is they get the problem statement from the customer, and then we'll wire up all the sensors onto the apparatus, I guess it's called, and let it run over time and normalize and see what are the typical cycles and have them tell us, here's when we started milking, here's when we stopped, here's when we sanitized.
Okay, so it's really based on saying, this is normal data, we're going to figure that in, and then we'll start plotting. Once we know that, then we'll start plotting.
Right. And then in the case of a compressor cycle, that can vary over time.
Right.
And so we'll build in then a layer of, what's considered normal, and then every once in a while you might get an alert, but then it'll normalize again to be the new normal if that's acceptable. Okay. And that's a hugely important part of the business, because that's what allows us to ignore false alarms.
Yeah. Right.
Yeah. Good. Was there a question over here?
It's always interesting to build a business against something that's never been done before. So your competition was a pen and a clipboard. Are you finding now that customers are trying to do all of this themselves, and that's actually helping you?
With the pen and clipboard?
No, like they're actually trying to build automated temperature measurement
Yes.
systems instead of just doing it manually and all the pieces and parts, and then they realize they really need to come back to you.
That's right. I mean, so if we can, we have relationships with a lot of these customers, and we're constantly speaking with them, and we've solved a lot of the problems. And once we can convince them or show them that, hey, it's just easier to use the system. We have, if I go back to to set this up, you plug in the gateway to the wall, you push the power button on the sensor, put it in the fridge, push the power button on the screen, and stick it. It's got magnets in the back on the outside of the fridge. No wires. So the installation savings alone pays for this system. And one of the other major things that we had to engineer was, how do we transmit every 5 minutes for 5 years on 2 Energizer lithium batteries, 2 AA's. And that was a significant, my secret. Yeah, that's right.
But is there also maintenance to consider?
So the question is there maintenance to consider on the sensors?
Yeah.
Yes. So if you look at, see if I have a close-up of that. No. There's a jack, there's 2 jacks right here. And every year the sensors have to be calibrated by a lab. So there is a lot of maintenance. And then, in any of these given large chains, there are stores that are new, closed, moving, about 1 a day for some of the ones. So it is, it's a logistical nightmare.
Right.
But when you look at it as more than just a here's the hardware sale, but it's really a partnership.
Right.
That's when we've been able to get
I remember like doing an interview with somebody from Bank of America who talked about like basically, you know, every day we get, you know, 2 or 3 different Bank of America telling back in, you know, 10 years ago saying, you know, every day we get robbed, you know, 2 or 3 times, you know, because when you have enough branches, basically, you know, every day is a bank robbery. So, but it's the same concept, right? Which is, so how do you, I mean, I guess the question would be, how have you as an organization scaled up to deal with that? And also as you're kind of down the road expanding the portfolio of different services and so on that you're offering to your customers, how do you handle the roll up your sleeves aspect of it that's manual, human-centric, you know, sneaker net? How does that scale?
It doesn't, right? And so we our best friend and where we were, you know, essentially our DNA is in technology. So I think that anybody can copy these sensors, right? Anybody can do this now. But how we do it and how we get them out there, it's really hard to copy, so I'm not going to tell you.
But just maybe
Yeah.
maybe follow up question quickly. You recently moved to the cloud. I see here you have gateway, cloud, and you do your analysis for each customer. We are centrally collecting a lot of data in the cloud. Did you think about pushing some functionalities to the edge?
That's a great question.
I don't like fog computing, but let us go back to computer science and say distributed computing, whether computing, storage, analysis, and action.
Right. So I mean, everything old is new again, right? And you go to the edge, the cloud, or the edge, the cloud. And I mean, I love this question because it really depends on the solution. You know, if you're taking readings, you know, 50 times a second, and you need to react quickly, you got to be in the edge. And the latency on cellular, well, it's really good. You know, but it's got a little ways to go for that type of, you know, building automation. Yeah.
Still have time.
That's right. That's right. Verizon's working on it though. Was that sufficient? Yeah.
There is no answer.
There's no answer.
There is no answer.
Yeah.
The time will.
Solution dependent.
We need time.
Yeah.
Let's give Harry a big hand. That was a great presentation.
Thank you. Thank you very much.
We are literally getting that hook because they've got to get in here and the cleaning crew's got to get in and clean up this room. I wanted to do a panel and it would have been great, but we really have to be considerate of our hosts. I want to give a big round of applause for Don, Rahit, and Harry. Great job. Check out the Meet. Give us a good review on the MeetUp site. Good reviews always help. And look ahead, we got a meeting scheduled in July. I think it's July 19th. Also, I wanted to make a point. I am the editor of Security Ledger. We're an IoT and security focused news site. I know a lot of you guys out there have domain experience, and some of you, a very small number of you, can actually write also. If you're looking to do a little thought leadership, you got a blog post around a topic that you're really interested in, or you've got some research that you're sitting on that you are looking for an audience for, either shoot me an email, Paul at Security Ledger, contact me via the MeetUp site, or come up and just grab me after this meeting and let me know. I'd love to feature your work, okay? And thanks all very much. This has been great. Thank you. Oh, if you didn't get a discount coupon for the Security Things Forum in September, we got more of those too. Thanks, guys.
It does. You can scan that or just go to the short link. It's the same thing. It's just it's like an Eventbrite. I think that's a link to Eventbrite. You can just register. Okay? Thank you. Do you have carpool? I do. Thanks for coming. Yeah. Where is my car?
I don't know.
It's in my pocket.
I was hoping to give you my hand, but there you go.
Awesome. So I didn't even look at your car. What do you do with Elixir?
I'm the East Coast guy.
Oh, great. I've emailed with your CEO.
Hugo.
Hugo, yeah.
Yeah.
And I've been in events that he's been at and so on. So I've been going to reach out to him and see if maybe come in for the security things for him. I know Josh Corman is a big friend of mine.
When is? Yeah. He's
Late
coming
September.
Out, he's coming out in October for the IoT Security Boston.
Yeah, definitely. Okay. Because we're also.
And I've got him out here in a couple of days for a couple of days. I don't think September is probably my time.
Okay. Well, you guys might have some researchers or other folks, subject matter experts. Love to get you involved, because you guys are
Well, yeah, especially you when I see people standing up here. Nobody's.
Yeah.
Someone's email. And I know he's new coming in.
Yeah.
Okay. So that's what.
Yeah.
Yeah, I guess my cards too. You'd be surprised if we did flavor. Some of them can.
Great, absolutely.
I'm not a security expert, but I can get up and talk to them.
You know, so you
our security architect
Absolutely.
covers.
So, maybe an evening like tonight where it's like, especially if we could pair you with some other kind of complimentary users, like if you've got local engineering, that would be great as well.
You guys leaving, you know your way? It's even less than that.
You're
exactly.
Okay, well, let's go. I like the idea of maybe doing one. We've got this coming up every month. So
we started so long ago.
I could see, I don't know if they'll come up for it, but I could see the vote. That's partner. Because that speaks really well to our security story. They're a customer. They're selling a postage. That's fine.
Oh, is that right?
So it's government.
Yeah.
Hi. Jim Rosencrantz. My first meetup. This was a good one.
Good. Glad you enjoyed it.
Yeah, I was at the other IoT, and they were talking about utilities. They were saying they were having to split out.
Yeah, it's a bunch of these.
Yeah.
Each one has a slightly, there's
different.
There's lots of overlap in the Venn diagram, but each one is like this focuses a little more on security. The one that Chris was in is focuses a little more on how do you get funded, that sort of thing.
Cool.
Well, these are all important problems. It's just which one you're interested in.
And this one in particular.
Right. There's another one that's run by the GE guys. On the Predix stuff, which is interesting.
Yeah, they're actually, there's been lots of talk about it, but this has been interesting. There was a really interesting session with Predix and Pitney Bowes.
That's what I think of, and then I just
More of
think,
an
well, I think about it all by myself.
Technical.
There's no one to talk about.
There's
no way to go.
From way back when,
to
see them get
well, I read this. It was
reconfigured for all of us.
Great to meet you. Great. Thank you.
Yes.
Or like a CIO.
Direct descendant of Shakespearean.
That enterprise servers,
Rosencrantz,
Guildenstern,
and a Tom Stoppard play. Did you ever see that?
They're dead.
I saw that play when it was in Boston, a bazillion years ago.
Saw them as an engineer,
kind of a steering committee.
Some of the engineers.
Yeah, like that kind of thing.
Hours of conversation with literature.
But it is one that I went to, so that's good. All right, good. So that's great. I'm glad you enjoyed it, and keep coming.
Yeah, actually, I'm pivoting right now to the policy of the enterprise silicon side.
That's what I found seems to be the old line.
Yeah.
And that's we're in the process of there's a bunch of them.
Yep.
You can go 4 nights a week if you want to.
Yeah.
But
Yeah, summer's starting to cool off a bit.
I would be very open.
For better, for worse. How long has this been going? I guess.
I got involved about, 3 or 4 months ago, I would say. He's been doing it for about a year. So
What are people hearing? Because right now it's a good thing.
It's a great thing. Because you hear all the hype.
Which I like.
Great
job. I love it.
But what are people hearing about?
It's the Wild West. It's all the Wild
West. What are you
West.
kind of thinking about
And
shitting
I'm
for
old
an hour, being like, oh, I saw
I
it.
remember when semiconductor.
And what are the,
Right.
what
Has
are the
the
trends? What
kind
are
of
the
consolidation ever since.
Right.
And that's what this is the cool.
This is still the Wild West. We're still in, we're 49ers in San Francisco now.
Yeah, no, because, I mean, as you know, like, and this is an issue I think comes up to
Pleasure.
the show as
See
well,
you next
which
time.
is conferences, you can get presentations that are very curious and a solution, so it's sort of like the McDonald's, well, let us talk about making delicious hamburgers problem, not a solution. Delicious hamburgers at scale, but, and that happens in technology conferences all the time, and security as well, which is, I'm going to talk about IoT in a very narrow frame, which is suited to the particular solution that my company sells. And you miss...
I've got some of my
Yeah.
And so that's why
Or you end up talking about the few things that we kind of have a grasp on, like, identity authentication, where it's like, okay, we've done a lot of work on this issue, but we're not talking about, like, the rest of the iceberg, what's below the water.
And so, and you know how I asked you that bio question? I was actually, I didn't tell them, which is very West Coast. I went to bio
Yep.
and I was talking with a company. It's not the sexist company. Very much.
Yeah.
That is actually producing that and wanting to sell it. Folks.
Yeah.
But that technology absolutely exists.
Yeah.
And now they're going to smaller.
Right. Sure.
And be able to be
Yes. Yes.
and all kinds of
Sure.
around that. Like,
Yep.
okay, so now someone breaks into your phone, they can get your eye scan.
Yeah.
All that. And what can
Yep.
they do with that?
Yep.
You know, like if
Right. So on the one hand, like,
get it to Canada.
yeah.
Right.
So I'm speaking to these people and learning all this new stuff, and then I'm like, I think of all these things, and I think,